ChemQuest 47, The Reaction Quotient, by AbrarSyed. What is the reaction quotient? The reaction quotient is a number that tells you how close a reaction is to its equilibrium point. Unlike the equilibrium constant, the reaction quotient uses the current concentrations rather than the equilibrium concentrations. The symbol of the reaction quotient is Q sub C, and the formula is identical to that of the equilibrium constant. Here's a question. In 3.5 liters of solution, there were 0.35 moles of carbon monoxide, 0.42 moles of hydrogen gas, 0.129 moles of methane, and 0.38 moles of water. What is the reaction quotient of this mixture? The answer is easily found in a few steps. Step 1. Convert all mole measurements to molarity concentrations. The second step is to simply plug in all the numbers that we just found into the reaction quotient equation. The answer found will be 52.84. Why do we care what the answer to this question is? The actual equilibrium constant for the above reaction is 3.92. From a given point in a reaction, the products and reactants will change until the reaction quotient reaches and becomes the equilibrium constant, and the reaction reaches equilibrium. What change must occur in the concentrations of the chemicals in order to reach equilibrium? If the concentration of the reactants increases, then Q decreases. Q must decrease from 52.84 to 3.92 in order for the reaction to reach equilibrium. Here are a few practice questions. I will give you a few moments to try and answer these yourselves before showing you the answers. Here are the answers. For the first one, where Q is equal to 4.2 and K is equal to 12.5, Q must rise in order to match K. Thus, the products must increase, or the reactants must decrease, or both. In the second one, where Q is equal to 2.1 and K is equal to 0.45, Q must decrease. That means the reactants must increase, or the products must decrease. Now a flow problem. Consider the synthesis reaction of hydrogen gas reacting with nitrogen gas in order to produce ammonia, NH3. The K for this reaction is 0.5. In a 50-liter reaction vessel, there is 1 mole of nitrogen, 3 moles of hydrogen, and half a mole of ammonium. Will more NH3 be formed, or will more N2 and H2 be formed? Again, it is extremely simple to answer this problem. The first thing you would do is convert all the mole values into molar concentrations. That is easily done by dividing the mole values by the number of liters. Then you plug in the newly found molar concentrations into the reaction quotient formula. A value of 23.15 is found. We have found that Q sub C is equal to 23.15. The K for this reaction is 0.5. In order for Q to lessen, the bottom part must go up. By this I mean the reactants. Thus, the reactants N2 and H2 will be formed. You have now completed the lesson on the reaction quotient Q sub C.